Section 3.1, the constant E and continuous compound interest. I'm just going to do a few of the compound interest problems. For more examples, look at the notes on Canvas. Example 1, a bank offers a 10-year CD that earns 4.15% compounded continuously. If $10,000 is invested in this CD, how much will it be worth in 3 years? Well, I made sure to write down our formula for us. We've got A equals P e to the RT. Remember that A is the ending amount, P is the beginning amount, R is the rate written as a decimal, and T is the time written in years. So let's take a look at what we're given. So we've got $10,000 invested, so that's our P. How much will it be worth in 3 years? So 3 is our T. And how much will it be worth? Well, that's our A. We're going to be looking for our A. And they gave us our R up here. So we've got A equals 10,000. E, remember, change your R to a decimal. So move it 2 times to the left. Move your decimal 2 places to the left. Or divide it by 100. Okay, so we've got 0.0415. And then times our 3. Okay, and remember we did do a review section on this, so make sure to re-look at that if you need help putting it in your calculator. I've already put it in the calculator and gotten my answer. Okay, so we get $11,325.82. Okay, and of course I round to 2 decimals since we're talking about money here. But you can round to wherever you want. All right, part B. How long will it take for the account to be worth $18,000? Okay, well this time they're telling us what the ending amount is, and we want to use all the information that they gave us, but we're looking for how long, so we're looking for the T this time in this one. So let's go ahead and fill everything in. So our 18,000 is our A, 10,000 is the P again, E, my R was 0.0415, and then we're looking for T. Well, you'll see in the notes some examples on what to do if your variable that you're looking for is up in your exponent. Let's go ahead and go through this one. The first thing you want to do is get that e to whatever power it is by itself. So I need to divide both sides by the 10,000. So we get 1.8 equals e to the 0.0415 t. And then, well, we need to cancel out the e. Well, what cancels out the e? The natural log, right, has the base e. So if we take the natural log of e to whatever power, we're just going to be left with that power. So I want to do the same thing to both sides, so I'm going to take the natural log of both sides. And that leaves me with ln 1.8 equals 0.0415 t. And then to get t by itself, we'll just divide by 0.0415. Okay, and again, I've already put it in my calculator, so I got approximately 14.16 years. Okay, but if you wanted to round to the nearest year, that's fine. Just make sure you read the directions. They might specify where they want you to round it, so you should always look for that as well. Okay, example 2. A note will pay $20,000 at maturity 10 years from now. How much should you be willing to pay for the note now if money is worth 5.2% compounded continuously? Okay, well, they're telling us the ending amount after 10 years, and they're asking how much should you be willing to pay in order to get that amount at the end. So they're looking for the P in this one. We're looking for the beginning amount in this one, and they gave us the R, of course, right there. So let's go ahead and fill in everything for our formula again. So our A is $20,000. We're looking for the P. My R, well, move the decimal 2 places to the left, so 0.052 times 10. Okay, well, I need to get P by itself in this case. So in order to do that, I need to divide by the E to the 0.052 times 10. Well, let's go ahead and do 0.052 times 10. That gives me 0.52, just so that it's less to write down. So we're dividing by E to the 0.52. And then we've got P by itself over here. So again, just put this in your calculator to get your answer. And I got about $11,000, $11,890.41. Okay, and our last example, how long will it take money to double if it is invested at 4% compounded continuously? Okay, so it wants the money to double. So we're starting with our P, right? P is our beginning amount, and we want it to double to get our A. Okay, so A is going to be 2P. Your ending amount is double what you started with. Okay, so now we can fill in our formula. We're going to replace our A with 2P equals P E. The R is 4%, so move the decimal over 2 places to the left. And then we're looking for our T. Okay, well, it looks like we've got 2 variables, but if we divide by P, it's going to cancel the P out completely, and we'll just be left with the T anyways. Okay, so divide by P, you get 2 equals E to the 0.04T, and then we'll do our trick. We'll take the ln of both sides, which will just make this side be 0.04T. Oops. And then we'll divide by 0.04. Okay, and then put this in your calculator, and you'll get about 17.33 years. Okay, so look over the homework, look over the notes. If you have questions, let me know. And make sure that you check out the notes on Canvas.